Mathematics is a very important subject. You'll need it for almost anything like construction, money, fueling your car, baking, cooking, computers, anything. So since math is very important, our ancestors had to use it, right? So today I will be talking to you about one of the mathematics the Hindus made. This mathematics is called Vedic Mathematics. What is Vedic Mathematics, I hear you say? Well, Vedic Mathematics is an ancient Hinduism way to solve mathematical problems, such as what shape should a brick be, how many bricks do we need, what will it cost to build the bricks, and so on and so forth. Vedic Mathematics is also faster than modern math. These mathematical strategies were divided into groups, such as sutras, sub-sutras. Bharati Krishna Thira rediscovered the Vedic mathematics somewhere between 1911 and 1918. It was invented by Indian Hindus during the Indus Valley Civilization around 3500 BC, though before it was thought to come from the Vedas due to its name. After the Indus Valley Civilization, the Vedic Age was when signs of the first Indian mathematicians or ancient scholars were found, which lasted between the 4th century and 9th century BC. In this time period, a bunch of textbooks called the Sulba Sutras survived so that we could see what Vedic mathematics was. Now a brief history of Vedic mathematics. The Indus Valley Civilization. During the Indus Valley Civilization, Vedic mathematics was used to help with construction, making bricks and other construction materials, the same size and proper shapes. Also, decimals were used during the construction, so decimals might have started at this time period. Vedic mathematics was also used to measure the position of the stars in the sky to use the stars for navigation. The Vedic Age. During this time, a lot of stuff happened, so be prepared. During the Vedic Age, Vedic mathematics was mostly used to make sacrificial altars or the yoga the perfect shape. And now an over-exaggeration of those sacrifices. Oh, lords above, please accept this offering we give you. We give you a chain bike, a purple thing, some jeeps, 2 helis, and another thingy. Flame those vehicles. Now let the ritual music start. Hooga shaga, 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 hooga shaga. Okay, we're done. Bit stop. You can stop playing right here. The bit. Hey, dude. The bit's done. Hey. Oh, look. The bit's done. You don't have to do this. The 3 textbooks were made on how to construct these altars. The first of the textbooks was called Badhayana Subha Sutra, made by Badhayana. He was the most important mathematician at the time. He lived during the 8th century BC. The second was made by Manava. The textbook was called the Manava Subha Sutra. Manava lived between 760 to 650 BC. The third and final Subha Sutra was called Apastamba Subha Sutra. It was made by an ancient scholar named Apastamba, who lived in the 6th century BC. The specifications for a fire altar was so specific that it could challenge a modern mathematician. One of the specifications was that the fire altars must have the same area, but different shapes. There were also very large numbers during prayers. For example, there's a prayer or mantra used during the Ashimai Yoga. It used numbers from 100 to 10 to the power of 12. A very important landmark of mathematicians of the Vedic period was made by the Sanskrit grammar scholar Panini. He lived between 520 BC to 420 BC. His work touches upon Boolean logic. the null operator, and pioneering work in the field of context-free grammar, which its rules to describe all possible strings in formal language. This is relevant to maths because Panini's work on context-free grammar had found its way in modern-day computer programming. The year 680 was another period of development for Vedic maths. Pingala, a mathematician who was born in the 3rd century BC, he was a musician theorist, but during his work on enumeration of symbolic combinations, he stumbled upon what we now know as the binomial coefficients, the Pascal triangle. Though he didn't know the full binomial theorem, he pioneered the concepts of combinatorics and binary numbers systems. His work also contained the Fibonacci numbers. The group Jani mathematicians were people who liberated math from religion and made it its own discipline. The Jain mathematicians were the people who also came up with the concepts of infinity and multiple infinities. There were 5 infinities. The first was infinity in one direction, the second was infinity in 2, the third was infinity across area, the fourth was infinity everywhere, and the fifth was infinity across time. Jain mathematicians were also the first to use junior, which means the void or nothing, which is the same as the concept of zero. This leads to exponents, which leads to algebraic equations. The Bakhshali manuscript. The Bakhshali manuscript was written on birch bark, and as of 2020, February 1st, it still had 70 leaves. The exact age is unknown, but the estimate is the 2nd to the 9th century AD. This manuscript is very important because it was a compendium of all of what the mathematicians of the era knew. It also contained the rules of arithmetic and other math strategies. It was in this manuscript that we got Junior Bindu, Junior meaning nothing and Bindu meaning dot. This was sent across the globe by European merchants and now is known as zero. Now that you know most of the history, what is it used for in the modern day? Well, Vedic mathematics is used for construction, arithmetic, baking, engineering, science, algebra, and many more things that require math, because Vedic mathematics is basically the same thing as modern math, but made a long time ago. Thank you for listening. I hope you learned. Whoa! Sorry. Okay. Sorry. Bye. Oh, gosh.